Engineering Program, Director of the Energy Systems Engineering Program here at Lehigh University, and very fortunate to have an excellent presentation on FERC Order 2222 and implementing DERs by Danielle Croop. She's with PJM. And again, she'll provide an in-depth review of what the order entails. And simply put, it is one of the most important orders that will make sure that we are able to integrate large-scale DERs on the grid, on the bulk transmission and the distribution system. I've heard this presentation by Danielle in the fall, Energy Association of Pennsylvania talk, and I was so very much impressed. I just thought this would be an excellent presentation that our students could take with them as they go into their careers. So before have Danielle take the floor, just some housekeeping items. Just as before, this talk will be for roughly 60 minutes, and then we'll entertain questions and answers for the remaining 30 minutes or so. And I'll give first preference to students. So students, I'll ask you to unmute yourself. If you have a question, ask the question. First introduce yourself and then ask the question. And then once the questions from students are exhausted, I will ask the general audience to participate. There's two ways you could ask a question. You could ask orally, of course, or you can enter your question into the chat box. And between Susan and we will make sure all the questions are answered. All right, so the title of the presentation is FERC Order 2222 and implementing DERs, and speakers Danielle Croop. The outline of this talk, the presentation will provide an overview of FERC Order 2222 and the opportunities and challenges of integrating DERs into the wholesale market. The material will cover the topics on interconnection, market participation, and operational coordination of these resources. And Danielle Croop is the manager of the market design department at PJM, where she's involved in a variety of initiatives for the market design of PJM's wholesale markets. Since 2014, she's been heavily involved with the alternative resource market participation and balancing operations. Recently, her work has focused on market evolution related to energy storage and distributed energy technologies participating in the PJM market. Prior to PJM, Croop has had experience of providing engineering and project management support to large system integrations. Her prior involvement in a number of NERC subcommittees and initiatives. She holds a bachelor's and a master's degree in electrical engineering and an engineering management certificate from Drexel University. Welcome, Danielle.
Great, thanks. Welcome, and thank you for having me. I'm going to share my screen now, and hopefully you guys can see it. It looks like it is up. Great. Yeah, so thanks again and good afternoon, and thanks, Rudy, and everyone for having me. As the intro suggested, I am here to talk about FERC Order 2222. I do work in the market design group here at PJM and have had the opportunity and pleasure of working on the FERC order and PJM's effort and compliance to this order since it came out over 2 years ago now. So we are well on our way to talking about DERs and DER aggregation. Before I jump into the details of the order and DERs, I did have a little bit of a warm up here on PJM more generally, for anyone that is not familiar, and some of the efforts and responsibilities that PJM as an organization has. So to get started, PJM is an ISO RTO as part of the Eastern Interconnection. If you see here on the slides, the dark blue here represents PJM's footprint. We do serve 13 states in the District of Columbia. We are the largest ISO in the US. We take up about 26% of the Eastern Interconnection. And as you can see geographically, covering some major cities and some widespread area, we do represent about 21% of the US GDP. And so with that, we serve over 65 million people and have over 1,000 member companies within our footprint. Taking a step upwards, for anyone not familiar with an ISO or RTO, really our sole responsibility is to operate the transmission system and direct the flow of electricity. PJM has three major functions that I think are important for me to highlight. The first being our operations. This is the balancing of supply and demand in real time and transmission monitoring. The second is our planning function. So we look out 15 years into the future, ensuring that we have a reliable grid into the future for our operators to operate. And these planning functions can include transmission expansion, generator interconnection, among a number of other areas. And the last is the wholesale market. So the market at PJM is put in place to maintain and enhance reliability for our operations. And really, it is to design and facilitate the buying and selling of energy and other energy products, such as capacity and ancillary services. The industry shift. This is an important lead-in to the presentation on DER because there is an unprecedented number of changes in the power industry today, which I'm guessing most of you here on the call are aware of. But many years ago, there was a much less dynamic grid. There was large power plants. And as we move through this energy transition that we all talk about, currently, there's a number of shifting resources and loads that are playing into a lot of efforts that we as PJM and us as a larger industry are undertaking. And so on the screen here, we have storage and renewables, large integration of these types of resources, both on the distribution system and on the bulk electric system, bringing on solar and wind, and integrating energy storage onto the system. And coupled with that, we see a lot of what we call traditional resource retirements. In the middle here, we have distributed energy resources. This is what we're going to be talking about in short order here in detail, but resources that are on the distributed in nature and building dynamics into that grid. Energy efficiency is a big part, alternate technology. Really think about electrification here and all of the changes to, home electric heat or electric vehicles, as the picture suggests, and really different loads and load profiles that we're seeing. We have fuel swap here, and this is really referencing, I almost want to say something maybe in our past at this point, or something that we actually have much more experience with than some of the others on the screen here, but moving from a coal dominant type of fuel to a natural gas type of fuel. And some of these challenges, or there are some challenges brought with this as well, where coal, there are, coal piles, if you will, where you get your fuel, and natural gas is just in time. And so although we've sort of seen this transition, as we begin to rely more and more on our gas resources, we see the challenges with the just-in-time fuel delivery that you get with gas resources. And the last thing here is the customer behavior and choice. And this is really driven by a number of things, really customer preference, where there's large shifts in desire to be served by clean energy. There is customer behavior where you see like the EV charging, or you see large loads, whether they be like data centers or what have you, and really just changing dynamics on the grid that are occurring and upcoming. So this is to say there's a lot of challenges and opportunities ahead of us, and we're not going to touch on many of them today, but we will focus on the DER challenges and opportunities that we have within this changing landscape. And so this is really to visualize and summarize what I just went to. We had something much more stagnant and dynamic and familiar 10 years ago, and things are changing now and into the future. Really from I would say this has a bit of a markets lens here, but today we're looking at ensuring reliability at the least ensuring reliability at the least reasonable cost, valuing resource attribution, and market-based solutions to incent desired outcomes. And these principles here are not new to PJM, but maybe the way that we are addressing them will have evolution and change to make sure that we uphold these items as we move to a different future. And the last slide here before we dive into DERs is just for me to underscore, as I said in the beginning, PJM's number one purpose is keeping the lights on. And amidst all of this transition and these new resource integrations, this is still our number one job that we work to every day to make sure we keep the lights on. Okay, so let's switch gears here to DERs. In the next slide or so, I am going to introduce the FERC Order 2222 directly. But before we get into that, I do want to lay some groundwork that DER as a resource specific is not necessarily new to PJM. And so even today and 5 years ago, there is DER in the PJM footprint and the PJM market, but maybe not as robustly as we see Order 2222 laying the groundwork and as we see resource integration into the future. But today, on the wholesale side, we have over 1.5 gigawatts of demand response, and this participates directly in PJM's markets through our demand response program. They offer into capacity, where they are emergency and pre-emergency type resources, and PJM can call on them in an emergency to curtail and provide relief to the system. We also have some of our demand response participating in energy. We call this economic energy participation, where these resources are much more active on a day-to-day basis and they respond to real-time pricing signals. And we also have participation in our ancillary service markets. Our ancillary service markets are regulation and reserve. Regulation, for anyone not familiar, is a product that PJM uses to balance our supply and demand on a second-to-second basis, where we ask resources to quickly move up or down in response to a signal that we send them through our operations. And our reserves are resources that hold capability and then are able to deploy that when PJM announces a reserve event, typically for a sudden loss of generation, and we need to get a number of megawatts on the system in short order to restore frequency and reliability. And so we have a number of demand response resources participating in both those markets, regulation and reserves. As you see here, we do have a breakdown of the types of resources that participate in demand response. Something worth calling out here is demand response can be load curtailment, which you think of maybe as the most traditional sense, like load response, where you turn off an HVAC, if you will. But we also have a number of gen-backed DR in our market as well. We have diesel, natural gas, some other types of like heat modifier type installations, where it's a resource, a generation resource that's placed behind load, and they are able to turn on that resource to effectively reduce load onto the system. And they're also eligible to participate in our demand response today. We also have about 2 gigawatts of generators, front of the meter generators that participate under PJM's wholesale market today. Again, they offer into capacity, energy, and ancillary services. And most of this is going to be distribution solar resources as we see it today. And lastly, we do have over 12 gigawatts. And so that's a pretty big number, especially in comparison to what we see participating in the wholesale market today. But we do have about 12 gigawatts of non-wholesale DER in the PJM footprint. And this can be a number of things. A large amount of this is solar PV, either retail or rooftop solar. But we also have a number of other installations where we have either like resilience DER and some small microgrids, or municipal DER where they are installed at the municipal and have either distribution level generator connected to either serve load or in sort of a backup type of scenario. And so in summary, DER isn't necessarily new, but the wholesale participation, as you can see, about 3.5 gigawatts is maybe small in nature in comparison to the DER that's installed in the system or potential DER into the future. Okay, well, we all probably have been waiting for Order 2222. And so this order came out back in I want to say it was September of 2021, and my memory is somehow escaping me, but a while ago now, where FERC put out what they coined as a landmark order for DER's participation in the wholesale market. And the punchline to this order was to allow DER aggregations to participate in the wholesale markets where technically capable, taking into account physical and operational characteristics. And what this means is FERC put out this order really to take a look at potentially removing barriers and allowing streamlined participation for DERs into the wholesale markets. It is important where they identify where technically capable. So they said, administrative barriers or artificial barriers should be removed, but DERs still have to have the technical capability to participate, really upholding that reliability function. And the market needs to recognize and account for the physical and operational characteristics of these resources. The aggregation of these resources plays a part into a lot of the design and participation models that PJM discussed and put forward in our compliance filing. And so there's a couple important definitions to level set as well as we get into the details. And so the first definition that FERC put forward in this order is a distributed energy resource, or a DER. And this is very broad. They say really any resource located on the distribution system or any subsystem thereof can be a DER. And so this includes the things we talked about, our demand response resources, our distributed generation resources. But FERC made sure to, again, keep this very broad and said this is also including but not limited to things like electric storage resources, EVs or electric vehicles, thermal storage, energy efficiency, etc. And so really anything that's on the distribution system that could either generate power or curtail their power would be considered a DER. And these individual DERs were able to aggregate, come together, create a virtual power plant, sort of any of those terms that you may be familiar with, to participate in the wholesale market. And so because they've defined this aggregation and the ability for multiple resources to participate, FERC also defined a DER aggregator. And they say that's the entity that brings these DERs together for the purposes of participating in the wholesale market. And so these two definitions will be important to understand as we go through sort of what the FERC order said in detail and some of PJM's efforts to designing a framework around DER participation. Okay, this slide here it says a lot, and it really gets into the nuts and bolts of the order. As I had mentioned, FERC coined the Order 2222 order as a landmark order for DER participation in wholesale markets. And the reason, or maybe one of the reasons why the coin landmark order came to be, is because they provided a number of directions that sort of shifted probably the current paradigms or abilities for market participation as they existed today. And so there's a couple different areas that I want to cover to give you a summary of what some of those are. The first is on the jurisdiction and interconnection. This is a big piece to the order where FERC addresses the state and FERC jurisdiction over the DER and DER aggregations, their interconnection, and their operations and market participation. And namely, what FERC did was they said that DER interconnection is solely under state jurisdiction. That means for a DER to interconnect to a distribution system, that would be state jurisdictional. And then that DER would not need to be looked at or studied or go through the PJM interconnection queue to participate in the wholesale market. This is something very new to participation, where currently today, resources have two options to come into PJM. One, they can be under the demand response program, where they do not have interconnection requirements, but they cannot inject energy into the system. It could only be load curtailment, and so you can only bring that measurement down to zero. You can't inject energy. And so if you did have the ability to inject, then you had to go through the PJM interconnection queue and either participate in, sort of in the front of the meter to provide some simplicity here. You had to participate in front of the meter and be studied by PJM. And that brings from a DR or a DR aggregator's perspective, that brings a lot of time and money to do that. And sometimes if you have a small amount of a small resource from a megawatt perspective, say 0.1 megawatts, to go through the PJM interconnection process, even though we do have some streamlined ability for like small interconnection requests, there's still the time and money involved sometimes did not shake out for their participation. And so putting this interconnection change where these resources would connect solely under state jurisdiction provided a potential easier pathway for DRs to participate. The operations and market participation, well, let me say the operations participation was also something that FERC drew a line on, which was important really for this coordination effort that I will get to eventually, but made it clear where the utility would be able to step in from an operational standpoint and where PJM would be able to stop in from an implementation or operations standpoint. And what they said was the DER, remember the resource that's on the distribution system, it can be anything, that resource is jurisdiction over the state or the utility, where that resource operation would be still state jurisdictional. But then the aggregation, the collection of DERs that participate in the market through that aggregator, that's FERC jurisdictional. And PJM operations would be able to dispatch or or curtail or direct the aggregation of resources according to their participation. And so those are two very important and new lines that were drawn under Order 2222 for these DER participations. The second pillar that FERC addressed is operations. And their operational direction was ensuring that operational viability of these DER aggregations in the wholesale market took into account the needs of real-time operations for reliability. They said a couple times in this order, blah, 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 upholds reliability, blah, 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 ensure reliability. And so they made sure that the operations and the operational framework were still upholding reliability, both on the transmission system and the distribution system. The T&D lines get completely blurred. Again, another landmark order under 2222, and I'll touch a little bit on that again in the coordination, but they made sure they address that in the operational framework. And so what items that FERC had PJM and the other ISOs take a look at in the operations of these resources is locational requirements, sizing requirements, data requirements, telemetry requirements, to make sure that we were getting the visibility and the dispatchability of these resources that we needed on the transmission side and on the distribution side. And so what PJM did here, there's a couple important points that I want to touch on. The first is from a sizing perspective, PJM made an important decision that resources 5 megawatts or less can participate in this DER aggregation model that we put forward, but resources larger than that would not be able to. And there's two drivers to why we did that. One's on the operations side and one's on the planning side. And the drivers are really around the transparency and controllability of these resources. Because remember, the DER aggregation model is going to allow a bunch of DERs that can participate together, and you lose some individual visibility and controllability when you aggregate resources. And so operationally, they said anything over 5 megawatts, we need to have direct control over because that can be material. And then from a planning perspective, anything that large that may have some sort of injection and impact the dynamics on the systems needs to go through the PJM interconnection process so that we can evaluate any impacts or needs for upgrades for reliability. And then the second thing that was important in PJM's framework proposal is the locational requirements. And I will tell you from a process standpoint, through our stakeholder process and through FERC, the locational requirements, I would say, has been the most conversational item where there are contention around how we move forward from a locational perspective. And the locational requirements that PJM put forth is largely a nodal framework. And so there's some caveats to that, which I'll cover next, but I want to explain the locational requirements and the nodal framework that we're putting forward first. And that is to say that for energy participation, resources, DER aggregation resources, have to aggregate nodally. And nodally means a transmission node. And so a transmission node, I want to contrast to a distribution node where there could be a number of points of interconnection on the distribution that all end up rolling up to one, transmission piece of an equipment or a transmission node on PJM system. And so that would be considered nodal, but you can't take two transmission points and put them together because that would be considered multinodal. And so PJM put together this node or proposed a nodal framework for energy participation. And the main underlying driver and why PJM thought this was so important to our proposal is, again, reliability focused. and really looking at constraint control on our system and the ability for our operators to use these DERs to effectively manage congestion. Why do we think we need to use these DERs to effectively manage congestion? Well, we asked ourselves when we started to design the Order 2222, what does DER penetration into the future looks like? And nobody has a crystal ball. And so nobody exactly knows what DER penetration will look like and how fast they'll interconnect and what type of wholesale participation will be. But we said there's the possibility of having DER be a material impact to our operations. We can see maybe a 16th of our fleet, which is still a large number, be DER aggregation resources. And so if you assume that, you have to also assume that these DER aggregations are going to replace our existing dispatchable generation. And ultimately, we need them to be used to control congestion and constraint control. And so that's why our locational requirements are nodal for energy participation. Now, why there is, some issue with the locational requirements is because this provides potential less avenue for participation. DERs, sort of by definition, are distributed. And so when you start taking large areas of distribution and say, okay, well, I have all these EVs in, say, the PPL zone, and can all these EVs, come together and participate as a DER aggregation resource? The answer is probably no, because they're going to have multiple nodes on the transmission system. And so some of the way the DER resources, and specifically the aggregators, may operate or find it best to operate, would not fit into the locational requirements of nodal in all cases. I told you there were a couple caveats to that rule. And so let me first say by saying all of this is still sitting at FERC. And so for this operations piece, and actually my whole explanation of PJM's DER framework, this is pending FERC approval. And so some of this can change. And the locational requirements is one important piece that is still sitting at FERC. And so what PJM has put forward today is the largely nodal aggregation for energy. But we do have a carve out, as we're calling it, where a small penetration of DER aggregation resources would be able to aggregate multinodal. And the reason why that made sense, or we propose it, is it's really sort of a stepping stone to getting to our largely nodal participation. In small fashion, there would not be a reliability impact to allowing some multinodal aggregations, and it potentially can facilitate the ability to get enough megawatts to participate nodally. The other struggle DERs can have in wholesale markets is you need to at least have 0.1 megawatts to participate. And some of these resources are small. They're 5 kilowatts, 10 kilowatts. And so you need potentially a large aggregation for market participation. And so we do have a carve out that allows some of that multinodal aggregation to occur until they get large enough to participate nodally. The second piece is our ancillary services. Our reserves and our regulation also can participate up to an EDC or a distribution company size. And that aligns with how we dispatch our reserves and our regulation today. We don't dispatch them nodally, so we don't have to aggregate them nodally. And in similar fashion, our capacity participation is done by deliverability areas. And so we do allow for that broader aggregation there as well. I'm going to move us to market design. Market design is allowing DER aggregations to participate in the wholesale market where technically capable. And this includes capacity, energy, and ancillary services. And so I touched on this sort of in the operations section, talking about locational requirements and sizing requirements. The market design area also touches on some of the ground rules for the DER aggregator and how they're able to participate in the market. And so there is a thing called DAPSA, as we call it. And so if you're familiar with PJM at all, we love acronyms. I think the industry as a whole probably loves acronyms. And so we call it the DAPSA, which is the DER Aggregator Participation Agreement, that facilitates that the aggregator is the is whom participates in the PJM market. And they do that by also adhering to all of the utility requirements for the individual DER. And so a lot of this sort of ties back to the jurisdictional item that I had mentioned prior, where the market participation is really aligned to the aggregator, and we dispatch and assign market commitments to the aggregation. None of the market design, at least in very large part, touch the individual DER resources. The settlement, I'm now on the green box, so the fourth from the left, was also a big piece in the 2222 order. And really, so in two parts. One, the accounting and settlements for the DER, both at retail and wholesale, that needs to occur. We need to preserve that, but we also need to prevent double counting activity. And so to prevent double counting activity is, generally speaking, easier said than done. And that's because the accounting and the metering principles and realities are very complex. In addition to this, FERC also said that we need to uphold Order 745. And 745 is a demand response order that put a bunch of demand response rules into place, but most importantly in this case, settlement rules on when resources should be paid LMP and how those resources get settled. And so under the settlement framework for the DER aggregation, we did put in bifurcated rules to settle the DERs, both for demand response, which is the load reduction, and then the generation, which is in the injection. And so you could have an aggregation that includes both, and then you would bifurcate it in the settlement process. But the more interesting part, and again, another item that stirred a lot of discussion in the design of the DER model, is the double counting. And this really spawned discussion on net energy metering resources. And so I think it's worth me spending a little bit of time specifically on that, just to lay out some of the arguments and really, intricacies and challenges on some of the DER model. So NEM resources, or net energy metering resources, in a general sense, are solar resources on the distribution under a NEM tariff with their utility, meaning they get compensation for their solar production and injection at that site. And they are typically compensated in what people coin as the all-in rate, meaning that they get paid for the energy, but there's also other charges there. Basically, credits for capacity and energy, or capacity and ancillary services. And so the question becomes, in the DER framework, can those NEM sites, either the solar resource themselves or a co-located resource, meaning a battery that connected at the same site of that solar resource that's on an NEM tariff, so can the solar or that battery that's co-located participate in this DER framework under Order 2222? And so I think a simple-ish conversation that was had is, can they participate in energy, or would that be double counting? And by and large, that would be double counting because they're already being compensated for energy at the retail level. And so they can't be compensated again for that energy at the wholesale level. The much grayer conversation comes into play where you ask the question if they can participate in capacity or ancillary services. And the reason why it's gray is because they're not providing capacity and ancillary services, meaning regulation or reserves, to the retail grid, but they are being compensated for them because there's this all-in rate that has some compensation for capacity and ancillary services. And so what PJM put forth in our framework, that again, I will caveat, has not been approved by the commission, is a DER aggregation that has resources participating in these net energy metering programs are eligible to participate in capacity and ancillary services under the double counting lens, meaning we don't think that it's double counting for them to participate in NEM at the retail and then participate in capacity and ancillary services in the wholesale. On the capacity side, though, however, we did make sure that we were clear that a capacity resource in PJM has an obligation to provide energy. We call it an energy must offer. That means a resource with a capacity commitment has to offer their energy into the PJM day ahead in real-time market and then provide that energy if they are economic to do so. And because a DER aggregation resource on an M contract can't provide energy to the PJM system, they effectively can't provide capacity either, at least in today's current construct. Now, as you know, NEM tariffs change and requirements change, there may be an avenue in the future, but effectively, capacity would also not be viable for these resources because they can't ultimately provide energy. And then on the ancillary service side, regulation and reserves, you know, we've sort of put forward that we do see a pathway for those resources. And when the rubber meets the road, it's likely that battery that's co-located with the solar that may be able to provide regulation or reserves to the wholesale market. And we did not view that under the double counting lens. Okay, the last area, and I will be quick on this slide because I have some graphics to go along with this that I think are important. But really, again, when the rubber meets the road and we implement this coordination pillar is going to be the most important. This is a framework to make sure that there is coordination between PJM, the utilities, the states, the distribution, the transmission, and this is all in the lens of ensuring reliability and safety. We are blurring the lines of transmission and distribution. We're going to have resources on distribution that are responding to, you know, transmission dispatch through PJM. And there is a lot of system dynamics that we are going to have to learn and address and adapt with, but we need to make sure that we uphold safety and reliability along the way. And so FERC did recognize that in this order and put in a whole coordination framework that drives some of this to make sure that there is facilitation through all parties as we go forward on this journey of integrating DER. I'm gonna skip this slide just in the recognition of time. I was going to spend some time providing some background on some of our principles and how we sort of do market design at PJM and how we specifically looked at items under 2222. But happy to answer some of them in the Q&A or go back if we have time. So I'm going to move forward to the DER aggregation model framework. And so in the framework, we first put forward how these resources ultimately come into PJM markets. And so you see PJM markets all the way on the right-hand side, and this is participating both on the market side and the operations. But how do you get there? So starting all the way on the left, you see these component DERs. These are the EVs, the batteries, the load reductions, the solar panels. You see all of our pretty graphics here. Those are what's on the distribution system and are being interconnected again by your local utility and operating, deep down in your distribution system. Those resources are going to be aggregated together, essentially virtually, to participate in the PJM market. And so that's where you get into the second layer, where we have DER aggregation resources and DER capacity aggregation resources. The DER aggregation resources is the collection of the DERs that participate in our markets. And these are the resources, again, that are going to have those requirements on sizing, location, different telemetry requirements that'll be able to participate. The bigger box, the capacity aggregation resources, this just represents that broader ability to add multiple resources together to carry a capacity commitment. And then these resources all get marketed and directed by that DER aggregator. And so you see them there in that blue box, where they are the ones that interface with PJM and they are our market participant. Here is our coordination effort. It starts on interconnection, which is a utility and state process, as I had mentioned a couple times now, but bears repeating on its importance and the ability to have sort of a streamlined interconnection. And then under the framework that PJM put forward, we have a very robust DER registration and utility review process. We have a whole operations framework, and then lastly, a performance, compliance, and settlement framework to make sure the resources performed, they adhered to their market requirements, there's no double counting, and we have appropriate settlements in place. So this here is our DER registration process. And if it looks like a lot and a bit complex, that's good, because that's the takeaway. But the reality is it's necessary, again, for safety and reliability and to uphold that coordination effort. And so in between the two dotted lines here, this is the full registration process that PJM put together. It is only 60 days long, which 60 days may seem like a lot to some people, but in the context of bringing these resources on as market participants, it is a very short window. I'll actually say through the compliance filings that PJM has made with the commission, we tried to actually lengthen this, but this was a directive from FERC that it is a 60-day registration process. And so within this registration process, PJM plays a part, the utilities play an important part, and the DER aggregator play an important part. And what happens in here is there is verification of a lot of data, making sure that the resource is properly identified in the utility system, making sure that they actually have the capability to provide services in PJM, making sure we understand where they're at the distribution system and how they map to PJM's transmission system, and making sure we have all of the data necessary to allow them to participate in the wholesale market. In addition to, you see that 45-day EDC reliability review, in addition to allowing utilities to perform reliability studies. And this was put in place because there's potential for some of the local interconnection processes to not necessarily capture all of the reliability studies that are going to be needed for these resources to participate in the PJM market. An example of this could be that a local utility has certain studies that they do to interconnect a resource, but don't necessarily study a resource providing dynamic regulation to the system, or potentially study coincident injections of a number of resources that would occur if they aggregated together and participated in the market. And so this reliability review is essential to allowing the utilities to do any additional studies for DER participation to make sure that they can participate in our market and still have a reliable distribution system. Following the 60-day review, we then do an approval window here. This is more administrative in nature, but make sure that everything, all the I's are dotted, T's are crossed, and we get the resources into the market. Here is maybe one of my last slides, but again, an important one on the operational coordination. Again, under that coordination pillar, making sure all parties are in communication. And this picture depicts real-time operations. How are we going to operate these resources reliably and make sure we uphold the reliability on the transmission and the distribution system? And so what we have here is PJM will provide dispatch signals to the DER aggregator under the operations function. Now, who is this party? It could be like a third-party entity, but the operations function is on the aggregator. And we will send dispatch signals based on their market commitments. So, provide 1 megawatt of energy, provide 2 megawatts of energy. Those types of signals. And that goes to the aggregator. And then that aggregator will need to move the individual DERs to respond to that dispatch signal. And they can do that through communication directly to the individual DERs. They can do that through communication through their utility, sort of however they have their infrastructure set up. And so it's important here to see that the PJM only talks to the aggregation, and then the individual DERs need to be controlled secondarily through that aggregator function. The other important point you'll see here is there's override commands. They go either directly from the utility to the DER or from the utility to the aggregator, which is the operations function, and then to the DER. And those override commands are in place if, say, PJM tells the resource go up 2 megawatts, but then that causes an overload or reliability concern on the distribution system. That utility can override PJM's commands and say, nope, not 2 megawatts. You have to go down to 0. Or maybe they curtail them to 1 megawatt. Some overriding function that the DER aggregator or the individual DER resources needs to respect. The utility has ultimate override control because they are the ones operating the distribution system. And then the last piece is you see some lines between the operations functions and the market functions, and that goes back up to PJM. Because the market function is an important infrastructure in place that the resources get commitments, and they also impacts their settlements and their abilities to participate in the market. Also, it's important for PJM to have valid and accurate data to manage our operations. And so any changes on the DER side, whether that be through outage or utility override, then needs to be reflected back into the PJM market systems, and that's done by the aggregator again. So that is what I have in closing. And so I'll go back to this slide here because I think this provides a good summary of really the breadth and depth that Order 2222 considers. And really, hopefully you have an understanding of the quote unquote landmark order that FERC says they put out. They touch a lot of areas: jurisdiction and interconnection, operations, market design, settlements, and distribution and transmission coordination. And some of this is important distinctions from status quo, namely the interconnection at the local level, some of the double counting provisions, and seeing how things evolved with retail participation and wholesale participation, the blurred lines between T and D, and making sure that we have reliable operations into the future, and really the wholesale market participation as a whole. Furthering the DER participation that we have today under the DR or the wholesale participation, and giving these DER resources a framework to aggregate and participate in the market. So with that, I will stop sharing and maybe turn it back over to you, Rudy, if we want to start Q&A.
Thank you, Danielle. Very interesting. Okay. Right. Let's see. As I mentioned before, I'm going to let the students have first dibs on the questions. Whether you want to go ask via your audio, or whether you want to enter the question in the chat box, is your choice. Any questions from the students' audio? Unmute yourself and introduce yourself before you ask a question.
Hi, Danielle. Alex Romanowski, master student, Energy Systems Engineering program. I just wanted to say I really enjoyed your talk. Was curious because I know the PJM interconnection queue is backed up to, no longer taking applications until 2026. So just the difference of this new framework for a 60-day interconnection. How do you think that's going to impact, some of the studies that you've been trying to, as a ISO, trying to aggregate all of these studies and look at the impact of everything that's in the queue, because there's a, massive queue right now. So how will these 60-day studies, is that something that's really feasible? Is the current study process just taking longer than it should? How is all that going to work together?
Yeah, that's a great question. Thanks, Alex. So a couple things that I think are important to mention. So first is these DER resources will have to interconnect with their local utility. And so that interconnection process will happen first. They need to get an agreement to come online at the distribution level. And then once they do that, the 60-day registration process for PJM participation becomes secondary. Also, I'd like to mention, which I had taken out of my slide deck, but was probably important. This DER framework that we're putting together, one, as I had mentioned a couple of times, is not approved by the commission yet. But two, there's an implementation window after we get approval of about 2 years. And so the DER model that will develop under 2222 is not implemented yet in the PJM market construct, and won't be for a little bit yet. That being said, on your direct question, I think that we see, value and appropriateness on not having these DER resources go through the PJM queue. Potentially, there's going to be a large integration of DER resources. And so to see that volume, especially those small 5-10 kilowatt systems through our interconnection process, would provide strain on our interconnection processes. In addition to, them being so small, we probably don't need to look at all of them on our large level. So I think there's some value there in doing that. We did draw a line in the sand of 5 megawatts because, larger resources, we did still see a need from a reliability perspective for them to go through the PJM queue. And so that's how it will operate. And so I think I see them as sort of two parallel paths, where we have our interconnection processes and the timelines and the volume associated with that, and we're working that down. And then these DER resources really will interconnect at the local level, and they'll be able to do that in parallel and then participate through the aggregation model when that becomes live through a 60-day process.
And then a couple of follow-up questions. Are there proposed co-location restrictions? So instead of having one 20 megawatt site go through the queue, which could take, very long time, breaking that up into 4 or 5 megawatt sites with, however many megawatt hours of battery storage, and then aggregating that and sending it in through nodal?
Yeah, so great question. We do put the sizing restrictions at the POI or the facility level. And so you wouldn't be able to take like 5 resources at the same site and like bypass the sizing requirements.
Gotcha. And then are there caps on the amount of that can be aggregated at one point, or is that just going to go down to the restrictions of the particular node?
Yeah, so we did not put a max on the aggregation. So from a, if you as an aggregator can aggregate a bunch of resources nodally up to say 100 megawatts, that would technically be viable through the PJM market construct. But we do believe there are natural caps in place from a utility system perspective. Like the utility system probably can't handle 100 megawatts of an injection, at one transmission node. And so I do expect some natural caps that will occur just based on the system topology specifically down on the distribution system, but we did not write one in the PJM tariff.
And then as more inverter-based generation comes online on the distribution network, do you foresee FERC 2222? Do you think that'll give PJM more power and control over that, and basically just be able to keep the grid more stable, because it's now, these resources are getting pushed up to the transmission level instead of you not being able to touch them at all?
Yeah. So, I mean, from a general perspective, I think there are definitely, operational challenges on integrating large amounts of renewables and specifically down on the distribution system. And so we need to make sure that we do that reliably and we make the, necessary upgrades or operational changes to do that. FERC Order 2222, I think, comes in both ways. One is it potentially provides some acceleration of that occurring because there may be additional market participation that developers see. And so we may actually see larger penetrations of renewables on the distribution that we would have seen otherwise. But then on the positive side, you're correct that having that market participation allows both PJM and the utility a lot more visibility and controllability of those resources, which is going to help operations.
And then last question, for states that currently don't have net metering laws in place, do you think this order will discourage states from continuing to pass net metering just because it's, all of the economic challenges associated with it?
Yeah. I don't know. I really don't. And I'm actually not going to provide my opinion there. But what I will say is I think this order will have both states with and without net energy metering tariffs in place take a look at some of their retail rate design and think about kind of what does our retail rate design look like in the future, or how do we want that to evolve with respect to the fact that we know that this DER model is out there or soon to be out there. So I do think it will focus states by and large to take a look at that, sort of how they evolve or their opinions on that. I am less, I don't know. In addition to, it's probably diverse opinions across sort of our footprint.
Awesome. Thank you so much for your time.
Thank you. Thanks for the questions.
Questions from students? Any more questions?
Spencer. I'm a third-year undergraduate. Does FERC have to incentivize renewable DERs over like fossil fuel DERs, or does the market already incentivize that?
So the market structures are in place, and those are, you know, by and large resource agnostic. And so depending on the market structure in place, there will be incentives for, you know, renewables or all resources to potentially come online and generate and, you know, follow PJM dispatch. FERC does not necessarily provide direct incentives for certain resources, but they do put out orders like they did Order 2222, where they make sure or try to ensure that there is a pathway to market and barriers or artificial barriers are removed for that participation.
Okay, thank you. And also, I was a bit confused about the part where you mentioned electric vehicles couldn't be used as a DER. Why is that?
Yeah, so electric vehicles are considered a DER and would be able to participate under this framework. They can participate either as like true load response, whereby the vehicle is charging, right? And so it's consuming power, and then it would be able to stop charging, right? And that would be a load curtailment. Or there is sort of like the vehicle to grid or V2G type of installations where they would actually be able to inject or curtail from the battery in the vehicle itself. And so the installations are actually at the charging stations or the individual homes if they've got the charger there. That would be the asset participating, and then the vehicle is sort of the generator or means of being able to participate in the market.
And so would like the utility companies be basically buying the electricity from the electric vehicle owner? Or?
Yeah. So, and actually, let me take a step back to say that EV participation is not particularly unique in the PJM footprint today. We actually have EV installations in our demand response program, you know, providing regulation service where they have a bunch of vehicles, they're plugged in, and then they're able to follow a continuous dispatch signal and essentially charge less and charge more based on PJM direction. And so that is a sort of a use case that would be able to be carried over to the DER model. But yeah, further, if you do have the ability to inject at those charging sites, they would be able to sell that power to the wholesale market. Now, let me add a layer of complexity that there's all the settlement rules and double counting, etc. But the simple answer is yes, the resource can inject power and, you know, schedule their energy and then be compensated for that at wholesale.
Yeah.
Okay. Questions from students? Please.
Hi, I'm Andy. I'm a fourth-year undergraduate. I was just wondering, how would this FERC order sort of impact utilities? Like, will it like sort of contribute to this like utility death spiral in a way?
Yeah, so we have spent a lot of time in coordination with utilities as we've been putting together our framework, and the utilities have also been working behind the scenes and will continue to do that. First, and you know, more generally, DER integration in a material way onto the distribution system is going to have impact to the utilities, right? They're going to need to manage all of those interconnections. They're going to make sure that they're able to support potential, you know, backfeed onto their system and really support, you know, different dynamics going forward that they did in the future. And so to that point, the answer is yes. To the second point is Order 2222 specifically has a lot of coordination efforts between PJM and the utility. We're going to exchange a lot of information on these resources. They're going to have the reliability review to make sure that they can participate in the wholesale. We're going to coordinate on locational requirements and making sure we understand where they're at on distribution and how they impact transmission. And then they'll have the override function. So they'll need to know how they're being dispatched by PJM and making sure that they don't need to override any of that direction for reliability. And so the second part is yes as well. They're going to have, when we implement this, they're going to have some additional functions that are going to be required to ensure effectiveness and safety, reliability, etc.
Andy, you okay? All right. Any more questions from students? So Danielle, just a quick question. You know, we've heard of virtual power plants, and are DER aggregators the same or synonymous?
Yeah, I mean, in my opinion, yes. So a DER aggregation can essentially be a virtual power plant. I think there's probably some like larger type use cases of virtual power plants that wouldn't fit the DER aggregation definition. But let's take a couple of, distributed energy storage resources, a couple batteries that are in an area that aggregate together for market participation. That's sort of how I define a virtual power plant. And that would be able to participate and be a DER aggregation resource.
Yeah. Now, this order 2222 limits aggregators to be less than 5 megawatts. Is that correct? Is there a reason why the number is so low?
Yeah, so the requirement that we put forth is the individual DER has to be less than 5 megawatts. But the aggregation, the collection of multiple DER could be larger.
Okay.
And the reason why we said an individual DER resource has to be 5 megawatts or less is when you start getting larger than 5 megawatts, there is the need for, visibility, dispatchability on an individual basis. In addition to, our planning teams may want to start looking at these resources in our planning studies. And what we're not going to have for the individual DERs that are smaller is distinct modeling or controllability. We'll only be able to do that at the aggregation level. And so when you start getting larger, there's a need for us to have individual visibility and control of those resources. Thank you.
Here's a question in the chat box, and I think this is probably very relevant. Are there any DER aggregators yet?
So, strictly speaking, the answer is no, because DE aggregators is the entity that participates in our DER model. That's not live yet. However, we do have what we call CSPs or curtailment service providers that play a very similar role to what these aggregators will play in our demand response space. And the answer to that question is yes, we have many CSPs that participate in our demand response program today.
And the other part of the question asked by Frank is, how do you become a DER aggregator?
Yeah, so from a PJM perspective, a DER aggregator has to go through some, logistical process. They have to become a PJM member. They have to meet certain requirements. They have to sign our DAPSA, as I referenced it, that, attests to their participation in our market, adherence to utility rules. And then essentially they can be the aggregator, and then they can bring aggregations to the marketplace.
So questions from the general audience? Please unmute yourself.
So hey, it's Frank Richards here. One follow-up on that other question is when you expect that any or all of this is actually going to be in place?
Yeah, great question, Frank. So we had proposed about a 2-year implementation to be able to make our software changes and our coordination framework changes to be able to go live with our model. And we still have not heard from FERC back on our finalized framework that they approved. And so we're looking at probably, 2026 or later at this point before the model will be stood up for participation.
Thanks.
Danielle, is PJM the only grid operator that is looking at this order, or are they the MISO and California ISO? Are they looking at it too?
Yeah, that's a great question. So, for better or worse, the FERC order applied to all ISOs under FERC jurisdiction, and so ISO New England, New York ISO, MISO, SPP, California, they're all in the same boat as we are. So they all have to meet compliance and stand up a participation model for these DERs. And just as a matter of reference, New York and California are a bit further along on their model than us. And MISO, SPP, New England is a bit behind on their model in comparison to us. And so at the end, how it all shakes out, I'm not positive, but I suspect if you're looking for sort of like the first implementation of this DER model, you'll want to look to New York and California. And then we probably would be the third in line to implement this.
Okay, questions from the audience?
There's actually a couple in the chat. One from Sajad Alshamari. Why PGM agree on location and other location? I don't understand the question. Sajad, do you want to ask that question? Why PGM agree on location and other locations not?
Yes. Hi, how are you? Just I'm asking about this. If you want to install some distribution or some generation, it's must be returned back to them to ask where I can install it, or just only install and that's it.
Yeah. So as far as installing the DERs at a certain location, that is preemptive to anything that PJM gets involved in. And so you as a entity would be able to install a DER anywhere on the distribution system, assuming your utility allows for that interconnection. It would be post interconnection and installation that resources would come to PJM for participation.
Oh, all right. Thank you for this.
Yeah, thank you.
Another question in the chat box, Danielle, from Tom. Are individual utilities telling PJM the volume or number of requests by DERs to attach to their grid? How many DERs does PJM expect in the next 10, 20 years?
Yeah, thanks for the question, Tom. This is the crystal ball question that I don't know if we know for certain. I think there is an expectation across the board that DERs will be interconnected onto the system, and especially in 10 to 20 years. I think there is some consensus that we expect sort of like a crawl, walk, run approach. There hasn't been any conversation on the order goes live and the next day there's hundreds of thousands of megawatts of DERs on the system. So we do see this as an approach that grows over time. And as far as the individual utilities, I don't have numbers to share, but I think, in my experience, some utilities expect more integration than others. We have a pretty diverse footprint, both from a state and jurisdictional level, in addition to utility and customer base level. And so we probably will see the integration in some areas grow faster than others. And so, that's my fluffy crystal ball answer that we don't really know. But as I had mentioned somewhere along in the presentation, that we put a line in the sand, like, what if 16th of our a 16th of our fleet are DER? Now, that's probably somewhere on the 20-year mark. Will we ever get there? I don't think we know. But I think there's just potential to see a material impact from these resources.
Any more questions in the chat box? David, go ahead. You have your hands raised. Unmute yourself, David. Can't hear you.
Ready to double mute. Danielle, thank you for the presentation. Definitely. Question slightly off topic, but you've got a way to bring this back on topic. As we think about non-dispatchable resources and how they might be added to the system going forward, it would seem like battery storage is going to become very important to us. And I guess I'm just wondering, if you think like a 10-year horizon, how would we know whether PJM would see a need to revise any of the market participation that might better finance batteries?
Yeah. Good question, David. And I think to bring it on topic into the DER model is that one of the market constructs that we put into place for these DER aggregation participation is that they will follow the business rules of the associated technology. And so an energy storage resource can have the opportunity of connecting either to the bulk system or the distribution system and participate in PJM under the same set of market rules. And I think that's important to make sure that there's parity and there's not an incentive to interconnect one way or the other based on market participation. As far as how the market drives, new resource integration, I think an important piece of this is some of the capacity reforms that we just put into place, namely the ELCC, and seeing those resource contributions and their effective, capacity commitments that can be obtained based on the storage duration. So that is a big piece of looking into the future and potential storage integration, what their value is there. We also, looking at storage and the energy storage resource model that we have in place now, and looking at enhancements in the near future for like state of charge management, and, changes around the edges to like make holes or opportunity costs, and making sure not necessarily like incentivizing, but making sure that there's a solid market participation framework in place so that when they are online, they can effectively operate in the market and in operations.
Thank you.
So Danielle, Tom's question kind of raised this the 10 to 20-year horizon. When you think about it, 10, 11 years, we made a pledge that the grid will be clean, 100% clean. So we should expect this order to be working towards that goal. Need to be achieved in the next 10, 11 years.
Yeah, I think it definitely could be a tool in the toolbox for states to use to help manage some of their targets or their goals if they can bring resources online at the local level, and then there is a pathway to market here. So I don't know if this particularly helps accelerate meeting those goals, but most definitely a tool in the toolbox.
Okay, I think we have time for one last question. You have a question for Danielle? Excellent talk, Danielle. And definitely this is going to be our last seminar is coming up April 22nd. It'll be presented by one of our alum, and Matt Rochelle, who's with Edison Energy, and Mike Sanford of Verizon. So we look forward to the last seminar, April 22nd for the semester. And again, thank you, Danielle, for your presentation.
Yeah, thank you. Thank you all for having me today.